Afternoon, folks, and welcome into the Resene overview of intumescent coatings for Steelwork webinar. Today we have Garth Moran from our sister company Altex Coatings presenting for us. Hello there, Garth.
Hey guys, how are
you? Before we kick off, I'll run through a quick bio on Garth. Now, Garth's the Australasian Technical Services Manager for Altex Coatings and has worked for them and within the industry for the past 19 years. He manages the daily operations of the Technical Services Department, supervising the team as required on inquiries from all areas of the industry regarding proper use, selection, application data and failure analysis of products or systems. Garth also provides technical and consultancy advice, particularly site corrosion audits to both internal and external customers, and also acts as the principal contact to various external agencies for Altex. And Garth is also a level 2 certified NACE coatings inspector. We will have time for questions today, and we've already had some come in prior to the start time. I've got a couple myself here as well. And given that I'm in control, I'll probably ask those first. But if you do have questions, please do fire them through. If we don't get to them today, we will come back to you as always after the webinar. Right, I'll turn my webcam off now. Garth's going to stay up on screen, and I'll hand over to you, Garth, to crack into it. All yours.
Thanks very much, Rob. We'll start today with just a bit of an overview of where we are with regards to the design for fireproofing coatings. I'll just get my screen up and running. So today I'll be talking about the design of fireproofing coating systems and the impact of the FBAN's Code of Practice for the specification and application of intumescent coatings. So I'll give a bit of an overview of Altex, where we fit, what intumescent coatings are, a little bit of the overall background with regards to intumescent coatings, and then we'll slide into talking about the impact or the guidelines given within the Code of Practice. So who are we? Altex Coatings, founded in total in 1954, one of the Resene Group of Companies, #1 market share position in industrial coatings so far as I know. We've had massive growth in fireproofing sales within recent years. It's continuing as we see it. We are highly committed to the fireproofing market within New Zealand, basing with technical service personnel representatives across the country and a wide range of fireproofing markets available within the New Zealand market. We are twinned in with technology partners in the UK as well as the US, through which we source a lot of our fireproofing coatings. So as part of the Resene Group, we're the heavy industrial firearm, marine arm of the Resene Group. So that's where we fit in. So what are intumescent coatings? They are thin film coatings that swell upon heating, increasing in volume and decreasing in density, producing a carbonaceous char, retarding heat transfer to the underlying substrate. And what is all of this for? Saving life. That's the underlying premise of these types of coatings. So they're not to be underestimated, and that's why we've had this Code of Practice come through, which I'll allude to later. So just to show you, if you've never seen videos of or the impact of what intumescent coatings do, here's a wee clip from a furnace. So you can see the heat expanding out the actual intumescent coating, and it expands anywhere between 20 to 50 times its original dry film thickness, and then effectively putting a wet chili bin, if you will, around the structural steel in order to protect it from the heat getting towards the actual steelwork itself. So moving on towards the FBAN's Code of Practice. So this was a collective effort between fire engineers, various council body representatives, all the major intumescent suppliers within New Zealand, contractors and third-party inspectors to lift the game of the New Zealand industry as a whole to where it should be. It had been for a very long time running very loosely within New Zealand. There was a collective effort made by all those within the group to lift that game, to bring it up to where it should be. We'd been working within this particular working group for about 2 years to get this code of practice up and running, and with also a review period out to various industry people, both engineers, inspectors, etc., to have a bit of say prior to its release in October of last year. We've made hopefully a very good effort to bring clarity to all the aspects of the process, from specification right through to the application and final sign-off of intumescent coatings. If you want to have a download of that particular document, you can capture it at that particular link that's at the bottom of the slide there. Just go along to the FPAN's website, and there's on the right-hand side there, there's a link through there. If you're cruising around on there, it's about 50-odd pages of various bits and pieces, as I said, right through from beginning to end of the actual process itself. So just talking a little bit with regards to fireproofing coating systems, we're looking into the specification and design considerations, what you have to look out for, what you have to be aware for when you're considering putting in an intumescent coating system. So some of the key considerations are much the same as your normal protective coatings, but you add into it, of course, the fire rating, the actual time that you need your steel to be protected for, the surface preparation required, system compatibility in between your protective coating systems and your intumescent systems, whether an aesthetic finish is required, cost can come into play, the ease of application of a particular material, and possibly even green star builds that can have an impact upon what type of coatings that you can and can't use. With regards to the type of intumescent being used, there's many and varied around there. The system is built around a fireproofing product that's correct for the environment given at a particular time. So with regards to those different types, you've got single packs, both waterborne and solvent-borne. Those have been around for a very long time. Of the more recent type, you've got the 2-pack solvent-borne. These can be of hybrid type, but typically of epoxy binder systems. You've also got vermiculite or cementitious type of fireproofing products, which I'll broadly just mention, but not go into detail with. We're concentrating on those liquid applied intumescent systems. You'll see a few of the pictures come up on the slides. They're just various examples of buildings that we've been involved in that have got fireproofing within them. So keep an eye out for those. There'll also be a little bit of a case history right at the end of the presentation, so you can have a little bit of detail with regards to the various different projects. So you're also looking into what environment is your intumescent system going into. So yes, you've got a macro environment as described with 2312 or 3404 with your corrosivity zones. So the vast majority of New Zealand is probably in a C3 type of environment. But what are your micro environments? Is your intumescent coating system going to be in interior hidden versus exterior exposed? Is it undercover, for example, versus fully rain washed? Is it going to be in a quasi-immersion type of scenario? Is there going to be any chemical fallout zones that you might be in a high industrial area or a geothermal area? You may recognise the pictures on the right-hand side at the very early stages of the NZICC building up in Auckland. As you can see from the lower right photo, you may notice there's the odd bit of water kicking around on the concrete floor there. So that was a fully enclosed building, but it was still having water coming through. So we still had to have a coating system design in there that would be fit for purpose with regards to its final commission form, but also be able to handle the conditions that you have during its construction. So again, you've got the duration of that construction time. How long is it going to be exposed for? For example, your interior enclosed steelwork may be a C1 environment, nice and dry in its final commission form when the building's finished and signed off, but during its construction, it could be fully open to the weather. And you could be having 3 months of construction time, or it could be 3 years of construction time. That has a major impact on how you design your systems. And again, by implication, is your during build construction during summer or winter times, or is it going to span multiple seasons over that particular time? You've got damp condensing environments that are going to be wet for a lot of the time. So all these factors come into play when you design your coating systems to be effective, at least. So as I mentioned right at the start, the Intumescent coatings are there to save lives. They're not just another coat of paint. They are a vital design element to maintain the structural integrity of the building, allowing people to egress and fireproof to enter the building for a specified fire rating period, and also to try and save the building if they can for a possible repair scenario. Therefore, they do actually require special attention to when you're designing your systems and for the application side of things to ensure that you get a successful result for what you want. So we get a lot of questions, and they can be fairly common that come up when we get asked to design fireproofing systems. And here's some of those questions and then some attempts to answer them as well. So I often get asked, what's kosher for attaching framework or framing to fire-rated steelwork? So within the code of practice, which echoes out the ASFP information, which is those that may be familiar with it with the yellow book, they have all sorts of guides come through in there as well. This echoes one of those. So you have to have your methodology proven by test by an accredited lab. Unless, if you don't have that, you have to have a standoff distance that must be created to enable the expansion of the intumescent coating to actually occur. For want of a description, an intumescent coating, as you saw in that video clip before, it's not a strong material. I liken it to a meringue pie. You can easily poke your finger through that material. It's not going to push anything off. It can be easily retarded by anything that's hard fixed to it. Hence the requirement for either testing or this expansion zone. So if you don't have the testing for going direct to, you can get around this by multiple methods, but some of the more common ones are Z clips, or clips that enable you to have a standoff distance from the actual main steel member. You can attach metal track stud fixing. So if you look on the top right hand side there, you can see a little bit of pictorial attempt there to describe what I mean there. So you have a metal track stud affixed to your column or your beam hollow section there, of which you can either post, add, or during construction prior to the actual coating itself. So the steel is in black, the intumescent coating is in blue. You can also use calcium silicate boarding to act as packers. So if you look on the bottom right hand side, there's a bit of description there of how to affix your jib plasterboard onto either a column or a beam. Let's just say it's a column in this particular instance. Using the calcium silicate boarding there to attach onto your fire-rated column, protecting those two particular sides, then using track stud and then plasterboard fixings indirectly into that metal track stud fixing. So the jib will burn away and will reveal the intumescent coating that will expand on those particular sides, and then calcium silicate boarding will protect the remaining two sides of that particular member. The other most common question that we get, what are the allowances for fixing attachments to fire-rated steelwork for different services? We then turn around or get asked, okay, so how big and how frequent are these attachments? What are the spacing of these particular attachments? Each of Each individual coating suppliers will have their own recommendations for the products that they actually supply, so seek their advice. But generally speaking, these items are pretty small. What you're doing there is to minimize the amount of area that you're exposing to the actual heat. That would provide a heat sink or failure point in the main beam itself. So those individual attachment points will be pretty small. If they go exceeding that, you've either got to find another way around them, or any direct attachments, you have to overcoat that with the intumescent coating itself to the same dry film thickness as the main member that it's attached to. Where do intumescent coatings stop and start between junctions of fire and non-fire rated steelwork, or secondary and primary steelwork? This is known as what's called Coatback Distance. Unless it's specified, it's necessary to protect the adjoining ½ metre of unprotected steel with an intumescent coating to limit any unwanted heat transfer between the non-fire rated and the fire rated. You'll get various measurements required. If you look worldwide, it usually varies in between 300 and 500 millimeters, but we as a collective group for the FPANs decided on 500 just for the sake of conservatism, and just make sure that you're encompassing all that you need to with regards to that minimization of heat transfer. What happens with composite flooring and fire-rated steelworks? So it's commonly known as common floor or tray deck. You can see an image above the table there. Anything from 30 and 60 minutes, the coatings manufacturers will increase the dry film thickness of a common three-sided beam by 20% to compensate for that particular keyhole shape that you've got sitting on top of the beam. Once you go to 90 minutes, that is increased by 30%. Once you go anything over 90 minutes, you've got to fill those voids by fireproof blocking. If you've got your comm floor in parallel with your beam that's going underneath it, that's obviously taken as a true three-sided member. That's when you've got them acting in perpendicular, that you want to follow these particular rules. The other common question that we get asked is about longevity and maintenance of your fireproofing systems. So again, this is taken from some of the information that's available within the FPANs document. Sets out in between water-based intumescents, solvent-borne intumescent, that's referring to both single packs with regards to the water-borne and solvent-borne. This particular one is taken from our lineup, so it's listed as hybrid. It's very twinned with the epoxy intumescent, very similar. So where we read hybrid, you're going to effectively read epoxy, but again, that's copied in within the FPANs. There is a difference in between your protective coating system and your intumescent system. Intumescent systems takes its priority because that's its main function. You can't just leave these coatings alone for 25, 30, 40, 50 years. You have to have some sort of life to first maintenance expectation in its final form. Any sort of maintenance scheme, you should be having a survey at least every year. There is certain Australian standards that give you guidance with regards to those timelines, which I can refer to you on later. But generally speaking, whenever you have, say, a 25-year life first major maintenance on, say, an exterior exposed bit of fireproofing steelwork, you're expected to make a spot repair to make good any sort of corrosion issues, reinstate any required intumescent dry film thickness, which would have been revealed from that corrosion, and repainted to replenish the protective top coat layers. With regards to the fully exterior, so if your lower right-hand column, C3, C4 environments up to 10 years, that 10-year period is specifically for your polyurethane films that are protecting your intumescent coating system from the UV, from the weather. And it's those systems that need to be topped up every 10 years or so. Once you go into interior C1 conditions, you've got a life of building kind of life to first major maintenance expectation. So once that's closed in, that will provide that level of surety that yes, it's encased, you can't get to it, but because it's in that C1 dry environment, it's not going to present a problem. The other common one that we get asking about 2312 systems or corrosion systems and intumescent coating systems. These don't apply basically. 2312 doesn't cover intumescent coating systems at all, and there's various other reasons why you can't do that with intumescent systems. There are limitations when you introduce intumescent systems to priming systems, and all for very good reasons, which I can go into a little bit later. No matter what your protective coating system that you're using, whether it be liquid coating systems, duplex between galvanizing or thermal metal spray, it's that 10-year cycle that you're looking to life to first major maintenance due to that topping up of the polyurethane layer. Typically, that's what's used, and that's what needs to be replenished in order to bolster up that first line of defense of the intumescent system that's been applied to your steelwork. The other common question that we get is how weather resistant are intumescent coatings or the coating systems? Most commonly the actual coatings themselves. So you've got an effect of exposure to weather during as well as post-construction, and they can have two different impacts. In order for least resistance to most resistance to weathering with no top coat, you've got waterborne materials, which are single pack obviously, and vermiculite fireproofing products. They've got virtually no tolerance. They may look fine, but the intumescent properties of those particular coatings, particularly so if they've been exposed to constant weather, particularly pooling and ponding or very high humidity, those intumescent systems will be very much compromised and or even dead. Solvent-borne single pack are much better, but still have their limitations. Solvent-borne, both two-pack hybrids and two-pack epoxy are the most resilient of those particular grouping of intumescents. You'll commonly see on data sheets weather resistant to 3 months. That's assuming that it's a rain cycle and it sits on the steel for maybe a couple of hours and then it dries off. Not your atypical New Zealand weather where you get torrential rain for a week and everything's sitting dripping wet for quite a number of days. All your commonly used intumescents have their limits to their weathering resistance. We're talking single pack here. They must have an appropriately sealed or sealer applied or a top coat applied during the construction, as well as for post-construction periods. You'll see on the photo to the right, we've had one of our products going and specified use onto our single pack solvent-borne intumescent. The grey on the left-hand side has been coated with our Altex Pro Seal intumescent seal coat, which is designed to keep water out, but also allow solvents out of the actual intumescent coating to keep on curing. For whatever particular reason, the right-hand side where you see the white has not been top coated or sealed off with the Pro Seal. This was a project in Ellerslie, I believe, by memory. Then that got cured off, and then for the preceding week after that, it absolutely hosed down. You'll see on the right-hand side there, circled, that there's been actual intumescent coating degraded and knocked off the flanges. When on closer inspection as well, the drip line underneath the flange was also affected. That was effectively a repair right there. The items on the left-hand side that had been sealed up properly, no effect on the actual coating itself, no compromise of the actual coating physically, as well as we took samples from it and tested here in our lab in Tauranga just to make sure that it still had the activation qualities within it and confirmed that it did. So it had done its job. That particular coating had been developed because of the knowledge of those single pack solvent-borne coatings have a limitation of its weathering. So that's enabled us to be a lot more secure within our recommendations of whether that system will be lasting during the construction period. You've got some other factors with regards to the choice of fireproofing, your fire rating on the section DFT. So with regards to low HPA affected steel or light section steel, you're resulting in high dry film thicknesses. With high dry film thicknesses, particularly with single packs, you've got more risk of solvent entrapment. That's the other common mode of failure that you'll see for intumescent systems. You've also got light versus dark color. Single pack intumescents can easily mobilize solvents through heating up of the film past the point of thermoplasticity at 40 odd degrees Celsius. You start to actually compromise the single pack intumescent's ability to fully react past 70 degrees C. The coatings chemistry themselves, the actual intumescent coating starts actually expanding up past about 150 to 200 degrees C. But once you start going past 70 odd degrees C, the actual chemistry, albeit very slowly, starts to build. And once that chemistry is starting to kick into action, you start compromising the amount of time that you've got left in there. We quite often see a combination of solvent entrapment with your dark colors. So any dark colors that are on intumescent systems that are not fully cured easily compromised, and you'll easily recognize those through large blistering on intumescent coated faces, especially northern facing sides for obvious reasons. And you'll easily cut open that film and you'll get a face full of solvent coming out of that particular material, and that's usually the root cause. You've also got the number of coats applied versus the cost of film build per product. So a lot of the 2-pack hybrids and epoxies, you can apply much higher film builds in one application compared with the single packs. Single packs, you're limited to 800 to 1,000 microns per day. Most of your 2-pack hybrids and epoxies, you can get 3, 4, 5,000 microns applied in one coat. It's quite easily done depending on each individual product. So you can get some project efficiencies and critical time lines being impacted there depending on the type of the intumescent that you choose. So further into the maintenance side of things, you need to maintain your maintenance of your intumescent system to maintain your structural integrity throughout the period. If you let your intumescent coating system be compromised, you're obviously starting to compromise the fire rating, which then compromises the building itself. So it's entirely reliant upon the integrity of the protective sealers or the top coats which shield it from its environmental factors. As recommended, these systems are inspected and maintained for damage to ensure that long service life that's intended within the specification, and the safety level is required to maintain a fire rating. An annual and program inspection, which may be included, scheduled washdowns, as well as the actual inspection, a thorough inspection of all the painted areas that you can get to, and a maintenance or repair situation of any sort of damage based upon the original painted specification or the approved equivalent. I'll quickly pass through some local case histories of some relatively recent examples. Obviously, we've been through a few, one of them being the NZICC building, which is undergoing its second round of build, shall we say, after the fire. We've been heavily involved with that particular building, been able to assist Fletchers and the insurance assessors, the many and varied questions that they've had with that particular building. In a nutshell, because of the amount of firefighting water that's involved in there, a lot of the basement areas had a huge amount of either A, water sitting in it, or B, the humidity that was present, and that had an effect upon the fireproofing systems within that. So the question of whether those were salvageable or not, we were able to have a helping hand in and give some expert advice upon. Victoria Street West Apartments, that's a job where we had an older single pack product of ours that was used upon there. You'll see the coating system is described on the right hand side of the slide there. University of Auckland Science Building, there's been another one come through as well. So a large amount of structural steel there. that was constructed in 2014, 2015, so that's an up and running building. The Fonterra corporate office on Fanshawe Street, that was one of the very first jobs that we did with the SE902 product. You'll see on that on the exterior steel well there, that's featured in the bottom left-hand side photo. Merchant quarter apartments, done again, a split between two different products there. It's quite a common approach towards projects split in between different products to get the most efficiency or the best cost bang for buck that you're getting out of your fireproofing systems. Somerset Hobsonville, stage 1 and 2, Somerset Ellerslie, main building and apartments. The Botanica apartments in Mount Eden. Again, you'll see there a bit of a mix of products. As a summary, there's multiple factors that must be considered in order to enhance both protective and fireproofing coating systems to achieve NZBC requirements, which includes your material or substrate choice, your environments in which they are subject to, your inspection and maintenance system regimes to show specification has been met and maintenance done to ensure the expected life has been met. Intumescent coatings are a critical structural element of the building. They must be specified correctly over the correct primers at the right thicknesses, have the appropriate weathering top coats or sealers applied. The fireproofing coatings are a standalone from 2312. They can be loosely applied to it, but they're not actually covered by 2312. Your intumescent coating systems must meet the required certification standards like BS476 or the Australian standard. QA must be provided in order to prove that the required film builds are met to gain the fire rating. Inspections and maintenance are a must to keep that fire rating of the building in place. The FPAN's code of practice is a must to follow for the correct outcome to be guaranteed for your particular project. So that's about me for the particular time being. I'll bring back in Rob to start off on our questions.
Yeah, thanks, Garth. That was super interesting. I have no doubt that everyone's attending today has learnt a fair bit over the last half hour. So, as I mentioned at the start, we have had some questions come in prior to today, and I've actually got some myself that I wanted to ask. Sitting on the technical lines and working in our specifier team here at Resene, we get asked some common queries. So I thought I'd just put these to you now, and we have had some queries come in actually whilst you've been presenting as well. So hopefully we can get to a few of those. One of the most common ones that we get at our end is shop primed steel that's just been power tool cleaned and comes to site, and then there's a requirement for an intumescent coating on it or fire rating. So what do we do there?
That's a good curly question there, Rob. It's an unfortunate circumstance there. There's one or two things that you can go down that particular path. The easiest way would be to introduce a cementitious or vermiculite type of coating on there with a tie coat. That is the easiest way around it, but more often than not, it's a visual or a aesthetic requirement for that structural steel. So then you're more pointing towards your intumescent coating side of things. When it comes to intumescent coating systems, the actual products are tested on blasted and primed steel with compatible primers, of course. Once you go outside the bounds of that blasted and compatible primer kind of combo, you're venturing into the unknown. You don't know whether a power tooled surface is going to perform, or the coating system is going to hang on to that power tooled surface in the event of a fire. So all your intumescent coating systems are tested on blasted and primed steel. That's what you're stuck with if you want to conform to the actual testing and how they're specified for use. You've got to go back that way. So in that particular instance, that's a case for reblast, reprime, and put on your intumescent system over the top of that. And that's another good reason why we encourage people to get a hold of the technical people like yourself and I to try to get there early in the specification stage, so you can avoid that even happening. So that's again a more proactive stance to take on that particular question. So hopefully that's answered that one.
Yep, and that is consistent with the advice that we're giving as well. So kind of got to start again when it's turned up with a shop primer on it. So another one that comes in a fair bit, and you might have touched on this, but existing buildings that's got intumescent coatings on them, how can we tell if they're still in good order and will actually activate in the event of a fire? Right. Okay. Yeah, it's a good question. All right. And we've had that as well. As I alluded to in the presentation, you can't always tell visually whether an intumescent coating is fine. You may look at a coating system, whether it be top coated or untop coated, and it may look like a normal coating. It may look fine, but that may well have been compromised due to weather or chemical exposure. There are a couple of different ways that you can test for that. You can take a sample from that and physically burn that material, see if it's going to be doing what it's supposed to be doing. But the more scientific way that you can approach that with is by gathering a sample and doing what's called FTIR on it, so Fourier transform infrared spectroscopy. And for want of a description, it provides a fingerprint of that particular coating, chemically speaking, and you can match that up against its benchmark profile, if you will. And if the two match up from the original, then everything's honky-dory. If it doesn't, there are certain peaks within that profile that will be missing, and that will tell you that it's either been compromised or the system's completely knackered. Mm-hmm. Excellent. Next one for you is, this is an interesting one as well. So often when we're specifying or assisting with specifications in the industry, our specifications don't actually always, we don't always get the information that we need. So what kind of information do you want when you're producing a fire schedule, giving the loadings for, say, a 60-minute rating for steelwork? And I guess the other thing is, we in the industry, or this side of the industry, throw that word around a lot, loadings. So I guess if you want to explain what that is as well. But yeah, what kind of info are you after? Because we're often short of that info when we're being asked for the specification.
Absolutely, absolutely. So when we're talking about loadings, we're talking about the actual dry film thickness that's required for a particular steel member to give its 30 or 60 or 90-minute rating. So again, that's what's been tested with each individual product. So each individual product will have a different DFT for a different section of steel. So for example, you will get a different film build thickness on a 100 by 6 SHS compared to, say, a 310 UB40 beam or column. As to information-wise, we certainly need to start with, obviously, what's the fire rating on it. You would be surprised how many times that we don't get that information. Whether your steel that you're rating is in a beam or a column for configuration or a bracing configuration, that can have an impact upon the actual loadings that's required for the actual fire rating. The number of sides that are exposed. So, for example, is your column hard up against a bit of speed wall, or is it underneath a bit of slab that's forming the first floor? That again also has an impact upon the heated perimeter of the actual steelwork, which has a direct impact on your loadings of your coatings. Whether or not composite flooring is involved, as per the presentation, that has an impact that needs to be accounted for up until a certain point. Obviously, that 20 or 30% increase from a three-sided item. That needs to be accounted for within there. And obviously, any linear meters or square meterage, that helps work out the total volumes, not necessarily particularly so from an architect's end with regards to submitting something for consent, whether it may just be easier just to rate everything on a nominal 10-metre rate, and that will at least still get you the dry film thicknesses, may not give you the total quantity, but you don't need that for actual consent purposes. So just to round that out again, you need to know the rating, whether it's a beam column configuration, the number of sides exposed, if there's any composite flooring involved, and if you've got them, linear meterage or total square meterage. Otherwise, coating suppliers can offer a nominal rate for you.
That's great. Yeah, and I guess to those attendees out there tuning in today, as you'll often see from our side of it when we're providing specifications early in the project and we don't have that information yet, where we can, we're always putting a note on the specifications to, you know, to advise that the job's not commenced before the loading schedules are actually completed and are issued in line with the specifications. So that does catch people out occasionally that jobs are underway and there's actually not a loading schedule to go along with it all. So now just on that as well, so quality assurance records, that's an interesting one for us as well. What kind of records should be kept on an intumescent job, and is there guidance on this in the FPANS document?
There most certainly is. So if you want some light reading later on, you can head to section 6 of the FPANS document, and that covers all the QA requirements for intumescent coating systems, right from start to finish, right through from the requirements for dry film thicknesses of your priming system to the actual intumescent coatings themselves. The FPANS document will set out, and again, it's an echoing of the main requirements through from ASFP, X amount of film build readings across the perimeter of a structural steel item. Those will differ from an I section to a PFC to a hollow section, and they will describe out how often that you have to do that over a linear length and what the total representation of that needs to be. Comments go through from the contractor side of things, third-party inspection, the levels of qualifications that you should have within both the applicator as well as third party. All this information is there to give the reviewing engineer who signs off the PS4's particular projects. It gives them the base information to work for in order to be able to sign off a building. There's too often times that there just hasn't been adequate QA just to say, okay, let me see the QA for this particular floor and make sure that, say, the 310 UB40s are up to scratch with regards to it. And more often than not in the past, there just hasn't been that information. And how do you know if you've got the film build on there if you don't have the records? So it's all about doing things right and doing it as it should be to enable that. Yes, you've got the confidence to say that you've got what you've paid for, as well as you've got process and the products in the situation that will do their job as they're required to in the event of a fire.
Yeah, that is a good. It's a good point you made there, as well as also for those attendees today that are project managers or supervising sites, is you want to see your contractors completing their quality assurance documents as the project's going. Even for us, wet film thickness gauges on site, so that measurements are being recorded and the documents are actually being completed as required. So it's an interesting one for us when we get called to site to have a look at some things that haven't gone particularly well. And I'm sure the same as yourself, first question is where the QA documents are on the project, and it's unfortunately at times not uncommon that they're not there, or they're not completed to the level probably that's required. So next question for you. We've probably got time for just one or two more, which is good. Can we specify an AS2312 PUR5 system to be included with a fireproofing system? So probably want to explain what that all means before you answer it, but yeah.
Okay, so this stems back from a comment that I made in the presentation. Good that someone's picked it up. So a 2312 PUR5 system details out a zinc epoxy or heavily loaded zinc epoxy primer at 75 microns, 200 microns of high build epoxy and 50 microns of 2-pack urethane. And that's typically what you'd be using in a C3 to C4 type of environment to give you a 25-year plus life to first major maintenance expectation for protective coating system. So I'm trying to combine a PUR5 system with an intumescent system where you might like to try and slip in your intumescent system in between your high build epoxy and your urethane, that's where you'd logically be putting it. That doesn't really cut it usually in most circumstances. Each individual product has its limitations. Again, this goes back to the actual fire loading testing that's been done at the fire testing labs overseas, where the steel is blasted and primed, and it's primed at a certain thickness, and that's usually sitting around the 150 to 200 microns dry film thickness. So again, if you start loading up 300, 400 microns of film build below your intumescent, how do you know that that is still going to hold in place in the event of a fire? Is it going to be compromised? Is the fireproofing system going to fall off at the end of it? You just don't know because it hasn't been tested in that particular instance. So that's where the 2312 or the PUR5 kind of reference starts to fall apart. We've got that compromising of the fireproofing system versus you want the film builder in there for corrosion protection. So when you go through to your coatings manufacturer or supplier for your specifications, they will know their systems. They will be able to tie in their priming systems and the sealing systems and top coating systems around their intumescent coating systems, and they'll be able to, 9 times out of 10, they'll be able to get, particularly in a C3 environment, you'll easily be able to get that 20+ year type of systems with maintenance. But once you start talking large amounts of life of first major maintenance timing, then you start to venture into the need for either galvanizing or metal spray systems, which will do the donkey work of the corrosion protection systems. But that in turn involves its own complexities and own issues with regards to getting things right with regards to coating systems, so particularly single pack materials. But again, go back to your spec writer, your material supplier, coatings manufacturer, and they'll be able to, or your tech service guys like us, and we'll be able to give you a real good helping hand to designing a system that will be best fit for both angles, both fireproofing and corrosion protection.
Very good. Now, I'll throw one more at you, and then I'll give you the rest of the afternoon off. I would say we have had a lot of questions come in, so to those that are asking them, thanks very much. We will come back to you after the webinar, and we will answer every one of them that have come in here. But last one for you, Garth. How do limiting steel temperatures affect intumescent coatings?
Good question. That's one of the items that I've forgot to include in that information that we need to properly write a loading schedule. So well picked up there. So limiting steel temperatures, that's a design calculation type thing done by the structural engineer that can have a direct impact on your film build requirements. Unless we're told otherwise, people who are writing loading schedules will design around what's known as default limiting temperatures, around 550 degrees C, 620 degrees C, depending on the type of steel and configuration that it's in. Anything above or below that will start to change the dry film thickness that's required to get a particular fire rating. So, but across all of those ranges, once you start to go down in limiting temperatures, so if you go asking for, say, a 400 degree limiting temperature, your dry film thicknesses will start to go up. Once you go over and above those default limiting temperatures, say 700 degrees C, your dry film thicknesses start to go down. The relationship in between low degrees limiting temperature to higher degrees limiting temperature and the dry film thickness that's required in there is non-linear. So you'll get to a point where you've got lower readings as you go downwards and limiting temperature, that can start rising quite rapidly. So you can get an exponential growth in film build the lower the limiting temperature. So it can have a dramatic effect, particularly on those lower limiting service temperatures. So that's definitely a must piece of information that we or the fire schedule writers need to know in order to give the right DFTs for you.
That's fantastic. That'll bring us to an end today. I'm sure, as I mentioned earlier, that everyone's there's a lot of info that people can take out of your presentation today. So thanks very much. For those out there that do have any inquiries, particularly around intumescent coatings, please do contact our friends at Altex. They've got a great team on the end of the advice lines there. I don't know, how many have you got? 4, 3, 4, 5 guys?
We've got here in Tauranga, we've got 1, 2, 3, 4, 5. We've got one guy in Australia as well. And we've got a few more than that outside of the tech team that will also be able to help you as well.
Great, that's fantastic. Now I'll throw in the contact details for Altex as well in the follow-up email that comes out, the automated email that'll come out tomorrow. So thanks to everyone that's tuned in today. We'll end it now. Stay safe out there, and we will see you next time. Bye for now. Thanks very much.
Thanks, Rob.